How's it going, everyone? Welcome. Elder Gonzalez here, and today let's going to talk about, I hope you can forget my setup right now because I don't have any lights. I'm just waiting for the handyman to come here. I hope that'll be the next month. But in the meantime, right, we want to now look at this intrinsic nature of the string. Specifically this course that I'm actually taking notes, which is made by Kyle Simpson, because we want to elaborate or we want to describe now is the pillar of JavaScript. And here is, you have now the type system, you also have the scope system, as well as the object system, right? And because over the couple days and weeks, we went through describe is the first type system, or the first pillar of the type system, and we first went through look at the primitive, what a primitive is, which is undefined, null, boolean, symbol, number, string, in big int. All right, we have seven, and also the non-primitive, which is anything that you can now add something, or in other words, an object. Okay, this is a way of how you can now describe the difference between a primitive and an object, right? Something that cannot be break down. So because of that, we're starting to look now at the undefined and null, their behaviors, and how you can now detect if a particular value is the type of, using the type of parameters, where that is gonna give you is this finite set of values, which is unfortunately due to the legacy aspect of JavaScript, especially ECMAScript 1 version, when the idea is that if you want to unset something, you use now undefined to do that. So for example, if you want to unset a primitive, you now use undefined. However, if you want to unset an object, you then use null. A null should return you now is this object like, right? That's the point. That's the main reason why we have now null, or use null back in the old days. Again, because we don't want to break the entire internet by changing something. The TC39 commit, they decide to drag that. In the other primitive that we look was to let me put it this way, because I want to, let me see, the type operator, we talk about the primitive, and also the link reference to the primitive, so where you can take a look at that, which is good, as well as now, I don't know why did I put it, okay, no problem, no problem. I don't know why I didn't put that here. That to me is quite mind-bending. In any case. All right. Okay. Let's take a look at this book here. This is the string. There you go. All right. String. Right here. But I want to point exactly to the string, which is by exploring at the types and grammar here from this, and there you got it. All right. So the primitive behaviors is like this. The primitive values. All right. So first we look at the primitive values. Again, this is a book for You Don't Know JS. And the intent here is not to offend you that you don't know JS, is that recognize that despite that your knowledge, there might some things that you don't know that actually fill a gap in your knowledge and therefore make you more competent as a JavaScript developer. Good. So one of those things is, understand the value types and how you can get now the particular values from that. I will also prefer to go to this primary types, okay, and how you can, on the spec, you can take a look at the primary types, right? Here it tells you what are the primitive, right? All of this, undefined, null, boolean, number, big int, symbol, and a string. And as you can see, 4, 5, 6, 7, and then we also have now the objects, right? All right, so this is part of the definition, and also to make yourself familiar with the spec, because at the end of the day, I think we are I think that this is one of the few community that we are known as guest professionals. And this is not a compliment. This is something that we need to address as a way to understand that how the things actually work, so we can get much more proficiency and be effective when we need to do this kind of solutions. We need to provide these applications here. So once we explore the value type as well as the type of, which is a way of how you can now get is the value of this, which is a finite set that gives you now a string. All right, and we also talk about is the non-objects, and something interesting here. One might explain the silent failure of example autoboxing. See automatic chapter 3, where the primitive is implicit convert to a string, so that we're gonna see that later. And an interesting thing is that yes, the value types. So the value types as well as the object, primitive, and objects. All right. Why do we even care about the type of? Any value type can be inspected via type of. So type of as values inspector. Okay, this is why we look at this. Let me in fact do something here and say this, right? The type of operator, or the type of operator as value inspector, okay? And I understand why this talk begin with this, with this particularly edge cases and so on and so forth, So what is doing this or this? I know why this workshop start with this, because it wants to not only entertain people, but actually draw the attention to what we really need in the community. So I think that's a very good, interesting approach of how that actually works. And I think that I'm gonna use that, despite that at the end of the day, I'm doing this is because I want to understand and be able to describe that. So anytime that I need to face some challenge in JavaScript, I know what it's doing. And there you get it, right? So, but unfortunately, since you're going to explain that to somebody else that is not you, so you need to find a ways to persuade them or to make easy for them to digest that kind of stuff. I think this is ineffective. Try to teach somebody about perhaps at the mechanical levels you can teach something, but when it reached to a certain point where the decision, the agency of that person, or in other words, is that the attitude towards this needs to pull off, or need to bring on, right? Unless that person truly, really wants that, then you will going to see that. Otherwise, then anyway. So in other words, so despite that, here we look at, and I think this is a very interesting law of Getifies. And I agree with that, which is anytime that your mindset diverges from how JavaScript works, that's when now a bug enters in your code, right? So the point of this is to, all right, recognize your own mind and your own agency, but when it comes to code, so align to what this JavaScript mindset is, all right? So, as I mentioned before, this is the types, the type system. We're going to talk about this particular topic, about the primitive and the object, as well as the type operator as like this, the type of operator as values, as a value inspector, all right? And now getting to the actual values here, which is, for example, is the empty values. So we talk about is the type of undefined values. I think we talk about that is kind of emptiness, and I really prefer to now pull all of this down below to this escape characters, line continuation, number, big int, corner cases. Okay, I would like to prefer to put all of these corner cases with string and boxing the string. Okay, so we're gonna talk about is the kind of emptiness, all right, and then the special values, okay, like no negative, type check exercise. And here's what we're going to talk about is this, right? Here what we're going to talk about is the primitive values, streams, kind of stuff. So yeah, so we talk about is the kind of emptiness, and especially here with null or empty values, all right? So type of null, and why null actually give you that, type of whatever, blah, 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 blah. And the type of non-existing expression is refers to as undeclared variable non-existent. We're also talking about is the nullish. So let me put it here. So empty values. Why are you doing all of this? Exactly, so empty values, right? No, make you, okay. So, personally, okay. So empty values, all right? So we talk about is the null and undefined, okay? So what is null and what is undefined, and also what is undeclared. Null, undefined, in undeclared. Null, undefined, or the kind of emptiness, right? So like undefined, undeclared, and this one. Let me put it here. All right, much better. Lovely. Okay, kind of emptiness. So the null and undefined, right? And Semantically null and undefined types both represent this. So for example, JavaScript provides a number of capabilities for helping treat the two nullish values and indistinguishable. For example, the two coercive equality comparison, nulls, that kind of stuff. Another recent addition to JS is the nullish coalition. All right. The other is this. So the null undefined here, as well as this one, the nullish coalition, nullish coalescing. That's interesting. What in the F doesn't mean that? Nullish coalescing. Okay. Coalesce, to come or grow together into a single mass. In Spanish, coalescente, which means to merge or come together to form one. Nullish coalescing. Interesting. To form one. Okay. Nullish coalescing. Coalescing. Jesus. Okay. Nullish coalescing. All right. This is something that we are quite familiar with, right? Yep. Exactly, because this, what translate this is into that. So for example here, but we also have another nullish coalition operator as a ternary equivalent illustrate like this. Check to see if my name is non-nullish, okay? And if it's so, return its value. Otherwise, it returns the other operand here, user. So if my value, okay, if the value exists, exactly, if the value exists, so you're gonna get the value. Otherwise, you're gonna get this null here. So this is the example here. The nullish coalition. And you may wonder, why do I need this? Well, it's to actually verify this type of empty values. All right? If they exist. So as a ternary equivalent illustrate, double check. Checks to see if my name is non-nullish. If so, return its value. Otherwise, it returns the other operand here, user. Right? So this is equivalent to say this. If my name, which is an identifier, is different from null, so assign that value. Otherwise, then use the user as it is. So along with the double, JavaScript also add the nullish conditional chaining. We got another one. Nullish conditional chaining, which is used in objects. The operator checks the value immediately preceding to the left value. And if it's nullish, all right, and what is the definition of nullish? Nullish, semantically null and undefined type both represents general emptiness or absence of another affirmative meaningful value. So JavaScript operation which behave the same whether null or undefined is encountered as referred to as nullish. There you got it. Null and undefined and nullish. All right, known as nullish. So you have nullish, right? You have nullish. So null and undefined null and undefined are known as nullish. Nullish values. All right, so far so good. No problem with that. Good. So yeah, so nullish values. So for a lot of JavaScript, especially the code developers, right, those two nullish values are interchangeable. So in other words, so we know that we have is the nullish coalescent value, whether this is a null or undefined. Okay, it's gonna be a use, if that's true, it's gonna be user. Otherwise, whatever value you have here. Now, there is another operator, which is the nullish conditional chaining, nullish coalescent, which is what I mentioned, and nullish conditional chaining, which is this one. All right. Can you transform that into what I mean? Okay. The operator check the value immediately preceding to the left value, and if it's nullish, the operator stops and returns an undefined value. Otherwise, it performs the property access against the value and continues with the expression. Just to be clear, record is saying check record for nullish, whether it's undefined or null, before accessing the property. And this description is important, bro. Of course. So what the nullish conditional chaining, okay, so what the nullish conditional chaining is, exactly, what the nullish conditional chaining, where are you? Okay, so what the nullish conditional chaining is doing is to check if the value at the left side, okay, if the value of the left side is nullish. If it is, return undefined. If it's not, then access to that property. Okay, or in other words, we're saying is that, hey, record, check the record for nullish value. In other words, from this example, hey, check record. Okay, so check record for nullish before, check record for nullish before, okay, check record for nullish before property access. Property access, okay. Additionally, billing address is saying check billing address for nullish before property access. Is this, hey, check record, hey, check record for nullish before property access. That's what we are saying here. You know, hey, check record for nullish property, for nullish before property access. The same for billing address. The same for billing address. Billing address. Hey, check billing address, nullish, check billing address for nullish value. Check billing address for nullish value, or for nullish before property access. If it is null or nullish, give now undefined. Okay. Some JavaScript developers believe that the newer is superior to this, and should thus almost always be used instead of this. I believe that's an unwise perspective. First of all, it is adding extra visual cluster, which should only be done if you're getting benefit from it. Secondly, you should be aware of and planning for the emptiness of some values. Secondly, you should be aware of and planning for the emptiness of some value to justify the use of this. If you always expect a non-nullish value to be present in the expression, using this to access a property on it, it is not only unnecessary, wasteful, but could potentially hide future bugs where your assumption of value presence has failed. But cover it up. As with most features in JavaScript, use this where it is most appropriate and use this where it is most appropriate. Never substitute one when the other is more appropriate. But again, if you always expect a non-nullish value to be present in some expression, using this to access property on it is not only unnecessary, wasteful, but also could potentially hide future bugs where your assumption of value perceived has failed. But this, cover it up. So again, the whole point of this is know that exists, know that you could use it carefully. Okay, there is also somewhat strange this from the operator as well as this. What you need to use is the array style instead of accessing that, which is, hey, check if the record is nullish. Check for record. Check record for nullish before accessing to this. And now here you're saying is check this property, okay, before for null before accessing to this. Yet another variation, an optional call is this. Because of that gotcha, I strongly dislike this operator form and cautions anyone against ever using. I think it is poorly conceived feature that does more harm to JavaScript itself and to programs than good. There are very few JavaScript features I will go so far to say never use it, but this is one truly bad part of the language, in my opinion. So in other words, know that that exists, you shouldn't use it. It is important to know that exists, but it is, or it can introduce much more class. It can introduce much more mud in your code to understand it. All right, so please don't. And the other is the distinguish. And the distinguish. It is important to keep in mind that null and undefined are actually distant types, and thus null can be noticeably different from undefined. You can carefully construct programs that mostly treat them as undistinguishable, but that require care and discipline by developers. From JS perspective, they are more often distant. There are cases where null and undefined will trigger different behaviors by the language, which is important to keep in mind. We won't cover all of this case exhaustively here, but here's an example. If you don't pass anything, it will assume that it's hello. If you pass something, it will assume that it's hello. If you pass hi, this, and if you pass null, null. The clause on the parameter, it refers to the parameter default. It only kicks in the assign its default value to the parameter if the argument in that position is missing, or if the exactly the undefined value. If you pass null, the clause doesn't trigger, and null is assigned to the parameter. There is no right or wrong way to use it. This is a corner case with the distinguish. Okay, especially here with the distinguish. What a corner case here. I would call it like a corner case. Okay, like a corner case. Yeah, like a corner case. Okay. I know that we might take this, but it's important to, as I mentioned, as a JavaScript developer, to understand now the new features of the language. It's in case of the empty values, the null, the knowledge collision, and so on and so forth. Okay? Just to keep in mind. So, in other words, the knowledge conditional chaining, and it can lead to more trouble. And if you're going to use the distinguish parameter instead of a function, beware that it's going to now cast null if you pass a value, if you pass a null value. If you pass undefined, of course, the trap will set up. Now, Boolean values, that's right, so I'm quite familiar with this. There is nothing different here. Yeah, the Boolean values, I don't need to go too much into this detail. Nothing has changed here. All right. All right. So I would like to talk about is this first. So the Boolean values. So the Boolean. All right. The string value. Okay, which is that. You know, string values, the Boolean values is only true or false. You know, is that true or false? Okay, you can flip characters to that. Then the get operator flip Boolean values, which is good. Yep. And then we get into what we really care and a long topic, which is the string values. All right. These string values, which to understand a little bit more of this, we need to go into the JavaScript encoding. All right, because a string is representing is with the single or single quote, double or single quote. Good. Now, those characters, all right, JavaScript character encoding, because Unicode, if you think that UTF, you think that you have heard about UTF or UTF-16 and you thought that that's all that you need to know, you're not even close to that. Because Unicode is just the umbrella term in which all of these char sets this variety of char sets such as USC2 now belongs to, as well as the UTF-16, which is a variation of that another character set that I mentioned. But again, the Unicode defines all these characters that can be represented universally in computer programs that follow from 0 to 104 times f. This kind of detail perhaps is not needed to know that, but I think that the more you know about this, the better off will be for you. Okay, since the standard notation of the Unicode is with the U plus 4 or followed by 4 or 6 hexadecimal characters. All right. So for example, if you want to represent is the symbol, hard symbol is this. All right, that's what is this hard symbol is. Okay, and this first group of characters is called as the basic multilingual plan. In other words, is this 0 to 75535, which is these 16 bits representations of all of these characters. And because ASCII character use now a 7-bit to represent that, which is the English language, there is a reason why you cannot use is the letter N on on domains. So because of this way of representation, and I don't want to dive in too much, just to briefly mention it, because we have these representations of UTF-16 that initially we can represent as this 65,000 elements, right? Elements that are beyond that are known as the astral plane. And I really love about this term that they used to describe that. And so the way it's represented is by using now two adjacent pair of 16 bits, all right, or known as the surrogate pairs, o pares en conjunto. So this is when now the emojis fields is here. So this is, for example, when you are looking at the fields, all right, or let's say a single emoji, and some of those emoji has even dark tones, because the more they need graphemes, which is this unit representation, this Unicode representation of those symbols, the more grapheme they need to represent that more variety. So for example, if we use now this, so for example, if we use now this as a length, all right, let's take a look now at the Google here, all right. If we now take a look at this, and then we ask about the length, it gives us now 2, which is quite interesting. And we want to know if we want to know what does it mean, we can say, hey, because these are now Unicode, which means that a value that is represent now a hash table or a table that has associated is a value and a number, pretty much like DNS works, all right? If you're familiar with DNS, I think that everybody are familiar with that, right? Good, okay. So if you do this now spread operator to understand what are this symbol is made of, okay, and we say console log of this, I mean split, of course, split those characters, right? I don't need the console log here to do this. Because it will give me, I mean, Jesus, I want to store this as a string or as a grapheme, say graphemes, okay, and then I want to know what those graphemes are. So grapheme. So as you can see, you say, hey, I cannot get is that. That's interesting. That's very, very interesting. What if I wanted to say this? All right. Split me that. So if I say this, unless I now spread that into that, invalid token. So I want to try to okay. Why doesn't work this? Yeah, why it doesn't work? Anyway, let's take a look now at the string behaviors like this. And I want to say that. That's interesting. If I do this, if I try to do this, and of course I want to get the length of this, it tells me that this is 2. But if I want to know about that, it gives me the composition. Okay, yeah, absolutely, it makes sense. Now, I really love about this example here, because as you can see, right, is this, all right, and we're looking now that actually give you is, so the length of this, so the length of this is now 4, which is, so of course something that we don't want, right? So if you say something like this, it will give you now is 4, But if you want to now get only the graphemes of this, it tells you, hey, this is 2, right? Why is this? And why now when you do this, it tells you, hey, the length of this, is 2, right? If you don't trust me, okay, you can take a look at this and say something like this. Length, I think we are using is, yeah, an invalid character here. It now is telling you accurately is 2. So we are now looking at this, but it's because of that, right? So why do we have this? So this behavior is due the way how now each grapheme, in other words, the Unicode value, which is the 16-bit, okay, is used to compose those meaningful emojis. All right, so far so good, because now we can understand about that, right? So you may wonder, is like, how do I want to get something that is more finite? In other words, we'll say, well, it's going to depend of your implementation of what your end goal wants you to do. For example, Twitter say, hey, the length of all of this will be 2, right? I don't care which graphing is, I'm going to now fix all of it to have now 2. Instead of, well, making that to fit into 1. So, in other words, again, this goes beyond the scope of today's video, but it's important at least to understand that anytime you're gonna work with this kind of emojis or grapheme, these compositions of this grapheme, because at the end of the day, as this will give you now is a composition of graphemes. Or in other words, a composition of unit codes that look like one single character. So because of that, right? Now we can jump straight forward. This to me is interesting because it doesn't recognize that Unicode. And if I say, hey, I want to now map all over them in each independent grapheme. All right. I want to now, for all of these grapheme, I want to check what is the symbol of that. You know, what is the Unicode? So you can say, hey, string. You have now this locally for us, this convenient method to say, hey, from code point or from chart code. In our case, it's from chart code, okay, which is the grapheme. So from chart code, right? I think it's going to pass exactly a value. So we need to somehow transform this grapheme into that particular value. The question is that how do you know what is the value the underlying value of that, right? How do you know about this particular value? That's a good question. That's a very, very good question. And the way to know about this is by saying, well, how this is made of. How is this? So by splitting this, right? If you split this, you can get now that. All right. But again, this is from code points. This is from code points, right? So what you can do is to pass that combination to that, right? So if you say now, for example, hey, I want to now know about the string, this string, and if I pass you this code point, can you tell me what it is? You say no, this is invalid. If I say you this as an string, invalid code point, okay. Okay. So I need you to pass is a valid number to that. So code from code point, from chart code. Now, because at the end of the day, that's what I want to at least show. That's what I want to show, which is this. All right. So I want to is just return is the graphene split that, right? So graphene split. And say we got all the graphenes. So when we console log the graphene, we're gonna have now two arrays, where the first is indicating is now this Unicode character, all right? This Unicode character, which is great. This Unicode character followed by the second Unicode character. And as you can see, if you use this Unicode character independently, it will not render anything meaningful, right? However, if you render them together, of course, they're going to now render that as expected, right? So because this part of this Unicode or Unicode points values are not part of this spec, okay, they of course exist, but they are meaningful when they are together. That's when you have now this abstract realm. All right. So that was perhaps a little bit long to understand, but I think that this is quite relevant, especially if you want to know more about this, about the string behaviors, such as string character access, how you can have access to this, as well as the character iteration, right? Something that I already wrote here. String behaviors like character access, okay, and how even though if you wrote a string and then you try to add a property, which is something that you think that you can alter, it will not affect that, okay. I will say that this is an interview question. Absolutely, that's a very good interview question. Completely, right? I will definitely ask that in an interview to see if you are now a senior or aka a junior, because unfortunately now the industry is moving so fast that now the role of junior it involves to know a lot of things. And I think this is part of the maturity of the industry and where we are. Another is the left computation, as I mentioned before, how this synth actually works. String characters, access, character iteration. Now we can iterate through our characters like in an array style, using is the for of syntax, all right? Or we can now is using is the known symbols, which is, you can think of these known symbols as private methods that certain object has to have access and modify certain behaviors. So for example, the iterable. So you can say, hey, once I save this into a variable, I want to have access to that particular symbol, all right? And any time, because you also can say is something like this. You can say, hey, I want to give me now is this meta programming or this custom hooks that I'm having inside of this object, for example, in a string, all right, you have that. I want to give me now these behaviors where I can have access to that. And this is applying is the pattern, the iterator pattern, that no matter how big this data structure is, it allows you to walk through one to another and so on. So good, awesome, completely. And the other is the left computation. As I mentioned before, especially if you are now comparing is between characters with some additional grapheme or the other representations, for example, teléfono and all that kind of stuff. And if you want to somehow needs to compare their length, all right, let's say you store that data in a database and then you want to retrieve that data, well, one way to compare that in the same representation is by using is the normalize from a string, right? So we're gonna talk about that a little bit more, and also understanding this this topic that I mentioned before about the astral plane and how now certain emojis actually are composed with much more graphemes, okay? And how these graphemes or these Unicodes actually is a 16-bit representation, aka a character, all right? And then we look now at the internationalization and localization. This is because now we as developers need to provide these kind of services to different cultures, right? So the Asia or Middle East or even South America or the US, of course, and Europe, right? And now also in Africa. So because we want us to tailor it that experience per culture, there is now a convenient way to do that, all right? And that is an example that I did yesterday to that I find out quite interesting. And let me put it this way. Is this one. And how can we use now the internationalization Collator to say, hey, only give me is and demo. All right. And only give me this and only give me this meaningful words, right? Especially with the internationalization segmenter. The collator and the segmenter. exactly with the collator, where we can now is compare is on the same local. All right. So string behaviors, string characters, length computations, internationalizations. And here we have, well, the particular idioma for this, internationalization collator that help us to compare words in the same locale. Okay. That's the main use case. So to compare locales, to compare local words, that's one of the main use case for that. All right. That's one of the main use case here, to compare the local, or to now get segment. Multiple word can be segmented using internationalization segmenter. Okay. So for example, the int segmenter here, for example, so the int collator to compare locales words in a specific language. All right. That's one of the main use case. And the other is to get the words. Multiple word string can be segmented using internationalization segmenter. The segment method from instance of internationalization segmenters return a standard JavaScript iterator, which the for of loop here consumes more on the iteration protocol in sync and async titles on the series. But again, this is, for example, how you can is use this. So to get multiple words in a specific language, segmenter is useful. So for example, like this. You can also here is provide other meaningful examples. So for example, you can also is provide now is other meaningful example, not only for that, but also in Arabic. So just like that, where you say is this one or this. And how now it detect that. And look at this. Now it actually changed that because it's left and right. And here is going to get now the next meaningful word. That's interesting. Exactly, because it goes from right to left. In this case, right? From right to left, in this case. Right and left. And I think this is another quite interesting example of this. The question is that what is this meaning? All right. What is the meaning of this word? Google Translator, because to me it's all graphemes. Holy moly, that's an all okay. Ah, I get it. I get it. Oh my god. Holy moly. Holy moly. Hello world. Interesting. Interesting. So if you do this, it's gonna get now is interesting that now it takes first this and then in the latter is this. So if I remember that at the end of the day, because things are going to be read by that, okay? Things are going to be read instead of from left to right, it's going to be read from right to left. If we do this, the alphabetic character here is reading right, but this perhaps not. Okay, because this is supposed to be the latter, and then this one, and then it thinks that this is the last one. But again, this is how you can split now words in other language. So Collator, segmenter is a good way of how you can now get the meaningful word of a text. Okay. And the Collator is a good way of how you can now compare text on the same alphabet, on the same specific language. All right. That's powerful. Bro. That's powerful. That's powerful to know. So string comparison, string values can be compared for both equality and relational ordering. Oh, and here we're talking about is the string equality. For both equality and relational order to other string. Using various building operators, it is important to keep in mind that such comparisons are sensitive to the actual string content, including especially the underlying code points from non-MVP Unicode characters. Both equality and relational comparison are case sensitive. Exactly. For any character where uppercase and lowercase are defined to make case insensitive comparison, normalize the casing of both values first with to uppercase or to lowercase, and then we have this. I don't know if he replied me. No, I don't think so. Well, okay. Oh, did it? Fuck that. No, I don't believe it. Lord, I never said that. What? Okay. What the French toast? Yeah, what the French toast is? No. What the French stuff is this? There you got it. Right. Oh, exactly. Oh, there you go. I did. Exactly. Is that? Okay. Now, this is the string comparison. String values can be compared for both equality and relational ordering to other string values. Using various built-in operators, it is important to keep in mind that such comparisons are sensitive to the actual string content, including especially the underlying code points from non-BPN Unicode characters. So this comparison is very sensitive, not only in terms of, are sensitive to the actual string content as well as the underlying code points here. Both equality and relational comparison are case sensitive for any character where uppercase and lowercase are well defined. To make casing sensitive comparison, normalize the casing for both values, to uppercase and to lowercase. So far so good. So the triple and double equal operators, along with their negates counterparts, such as the counterparts, the exclamation mark, double equality, and exclamation marks equal equality, are the most common way equality comparisons are made for primitive values, including string values. Okay. Exactly. So the triple operator, often referred to as strict equality. First, check this to see if they are the type match. All right. So you go through this strict equality. You can take a look at that algorithm, right, to say, hey, what it's doing, and it's going to check if they are the same type. Okay. If they are not the same type, then it's going to return false. If they are, all right, then it's going to return is now true. Return false right away. If the type match, then it check to see if the values are the same. For a string, this is per code unit comparison. Per code unit comparison. Each one of those characters are representing to this Unicode. I would like to know what is the Unicode, for example, of, just for fun, So what is the Unicode of M? You might wonder. You can say split here. But it's gonna give you this. What I want to know is the code point of this letter. All right. How can I know the code point of this? So code point of letters, of characters. All right. That's a very valid question to do. How to know the code point of a character in JavaScript? You know, char code at. That's right. You can get the char code at or the code point to. All right. So returns the UTF-60 code unit works for most cases char code at, whereas the other is return the full Unicode points recommended, handle all the Unicodes properly. All right. So string has this built-in methods. Okay, so string has this built-in method that say, hey, if you want to know what is this, the char code point, whether it's a char code at that position, all right, or if you want to know is the code point, which is the code point at that position, this will give you now the Unicode as it is. So it give you this, it give you A. So what it's gonna do is to compare those, right? So A, B, C, D, and you can see the number increase in the table that has now JavaScript internally. That's interesting to understand the code points here. Oh my God, did I call? Yeah. Oh, but it's stored in catch. Good. So if I want to know is the code point of this, all right, then look at this. It's bigger, right? If I want to know the code point of, oh crap. Okay, if I want to know the code point, for example, of an emoji, look at this. Now this belongs to 128,169. 69. Anyway, but yeah, is this. Holy moly. What the French toast is this? That's interesting. That's very, very interesting. Because we are going to get is that specific code point. Converting back from code points to what is that? Oh, that's interesting. But again, what it's doing behind the scenes is converting each one of those characters, okay, into a code point, bro. So you might say is this is equal to the code point at that. It's not going to be the same as one. Is you see? Is this one, because what it's doing behind the scene is converting is that. Look at this. Look at this. You might have heard of the oft-quoted but nevertheless inaccurate explanation, the difference between the double equal and the triple equal, that is the double equal compares a value while the values, well, double equal, triple equals compare both values in types. Oh, there is a typo here. Lol, there is a typo here. You might have heard the oft quoted but nevertheless inaccurate explanation that the difference between the double equal and the triple equal is that the double equal compares the values while the triple equals compare both the values and the types. You have a quote here. That's interesting. Okay. Submitting a change will write it to the new branch in your fork so you can send a pull request. Oh, okay. Makes sense. Makes sense. So is this. No, wait, what? Exactly, it's here. Is it the behavior of the character? The note here. So all I had to do is to copy and paste this and try to find this in your fork of this project. So now I need to look at that. Why it doesn't find it? Why you don't find it? Anyway, character iteration, length computation, and is this. What the French toast is it? The note for this. Exactly. Coercion and the note. By collecting several small changes into a single PR in separate commits. Ah, okay. 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 Okay, as you wish. And it's gonna collect them. It's gonna collect them. Yeah, you might want to collect anyway. But is that interesting? So they're gonna be compared is by code points. They're being compared. Look at this explanation, bro. They are being comparing. So for example, when you do is mama is equal to mama, right? So what's doing behind the scenes truly is to convert each one of those to a code point at that position, all right? And they now do the same, because that's what it's doing behind the scenes. It's doing as this comparison, character by character, right? String comparison. It is extremely common for developers to assert that the double operator is confusing and too hard to use without surprises. Thus, the near universal preference is this. I think that's totally bogus, and in fact, JavaScript developers should be defaulting to this and avoiding the triple is if possible. But we need a lot of more discussion to back such a controversial statement. Hold on your objections until we revisit it later. For now, to gain some intuitions about the coerced nature, the most illuminating observations is that if the type don't match, prefers numeric comparison, that means it will attempt to convert both operands to number and then to perform the equality check, the same as the triple equal. So as is related, our present discussion, actually string equality can do only be check if both operands are already a string. The double does not really perform a string equality check itself. If the operand value types are both string, just hand on to the comparison to the triple equality. If they are both no string, the coercive step in double will reduce the comparison match to numeric instead of a string. So for example here, numeric not a string equality check. We'll cover that later, but in any case, what is doing this double equal is to passing through that algorithm, the loosely equality. And the loosely equality says that if you don't know, this is a way to describe that you know that you don't know the type of this. Because if you don't know the type, that's what you are using as a double equal. Or that you are sure about the type, sorry. That you are sure about the type. Because you know how the things work. But if you are unsure about the type, that's why you're using triple equal. Because you don't know what is the end value, what is the end type of those value here. In addition, we have the object.is utility, which returns true if both arguments are exactly identical and false, otherwise no exceptions or nuance. Since triple equals and the assignment onto the end make it more strict behavior, I kind of half joke that the object.is is like the quadruple equal, exactly, and a string relationship in comparison. In addition to equality checks between a string, GS support relational comparison between primitive like string. So for example, minus or this and that. Less than or greater than that operations compared to string values lexicographically, like you will sort words in a dictionary, and should thus be fair, self-explanatory. Right? So as I mentioned earlier, the running JavaScript program has a default locale, and these operators compare according to that locale. That's what happened. That's what happened. So, local aware relationship comparison. Okay. Local aware relationship comparison. doesn't actually define the underlying greater than for greater or greater than or this. Instead, it defined them by reversing the argument of the less than completed counterpart. So x is greater than g, it treated by essentially as g is less than, equal, or greater than c. Or this is treated by essentially as g is less than c. So it includes that. So JavaScript only needs to specify how minus double equals works, and thus get the minus greater and greater equal for free. But here is this local compare. Exactly. Now that you have this another local compare from that. The optional second and third arguments to local compare control which locales to use. International Collator, you get this. Interesting. Because instead of doing this, you say, hey, this is now part of the English, and therefore you can sort that according to that alphabet. By passing now the compare to that, the compare function of the collator here. Holy moly, bro. Okay. That'll be all for this video. Take care. Bye bye.